Okay, question 15a, expand and simplify. So expand means get rid of the brackets, simplify means simplify. So 3x multiplied by 2x gives us 6x squared. 3x multiplied by 5 gives us 15x, and then 2 times 2x gives us 4x, and then 2 multiplied by the 5 gives us the 10. So we've expanded the brackets. Okay, all we need to do now is simplify, so we just need to join these two together. So we get 6x squared plus 19x plus 10. So that's our answer. Very easy, 2 marks there. Plus 19x plus 10. Okay. Part B, simplify fully. So everything in this bracket is being squared. So remember, the number has to be squared. So 3 squared is 9. Now x squared, and it's being squared again. So that's the same as x squared multiplied by x squared. And remember, if we multiply these numbers with exponents, we add the exponents. So we x to the 4. So we get x to the 4. And then y to the 4 multiplied by y to the 4 means we add these together, so we get y to the 8. I've made a meal out of this really just to show you why things are as they are, but you can cut corners quite easily. 2 times 2 gives me 4, 2 times 4 gives me 8. So I get 9 x to the power of 4 y to the power of 8. And we've done it. That's all we need to do. Nothing more, nothing less. Okay, so we'll move on to question 16. Okay, question 16. This is the sort of question that a lot of people are afraid of, but there's several ways of going about this. So a circle is drawn inside a square as shown. Okay, so we know the circle touches all 4 sides of the square. Show that the area of the circle is more than 75% of the area of the square. Okay, so this circle apparently is more than 75% of the square. We could use pure mathematics to do this, but it would be easier if we just chose a random value. Okay, so I've said that one side of the square is x. Okay, you don't have to put x in. You could just say one side equals 10 centimeters. Okay, so we're going to give that a value. So r must equal, that's going to be half of 10. So that's going to be 5 centimeters. Okay, so now what we need to do is work out the area of both. So the area of the square equals 10 times 10, which equals 100 centimeters square. Now I've chosen 10 because if the area of the circle is more than 75, then we can see that that's more than 75%. So the area of the circle is that. Area of the circle equals pi r squared. So this would equal pi, so let's say pi is 3.1 multiplied by 5 squared. Okay, so that will be 3.1 multiplied 5 squared is 25. Now you have to know how to multiply decimals together, so I don't want to multiply 3.1 by 25, I'd rather multiply 31 by 25, so I move the decimal point one place. So this would be 31 multiplied by 25. Okay, now over here I just do this 31 multiplied by 25. Okay, 5 ones are 5, 5 threes are 15, and then I put down a 0, 2 ones are 2, 2 threes are 6, and I add these together, so 5, 7, 7. So this gives me 7, 7, 5. So 3.1 multiplied by 25 would be 77.5 centimetres squared. Now 75% area of square, obviously 75% of 100 would be 75 centimetres squared. So I can say that the area of the circle is greater than 75%. Okay, it's that simple. So just give a value, choose a value at random, one that works for you, substitute that in, work it through, and then this now has proven that what they're saying is true, that the area of the circle is more than 75%, because we can see here 75% would be 75 centimetres squared, and the actual area of the circle is 77.5 centimetres squared. Okay, I hope that's made it a little bit easier, and we'll move on to the next question. Okay, so we have 17. N is an integer, so an integer is a whole number. So it says show that this is a square number. Okay, so if n is an integer and this is a square number, then we should end up with n squared. That's really all we've got to do. So first off, we need to get rid of the brackets. So n times n is n squared. N times minus 1 is minus n, and that's all over 2 plus, now n multiplied by n is n squared, and n multiplied by 1 would be plus n, and that would all be over 2. Now because they're both over 2, for example, just you wouldn't write this in the exam, but if I've got 1/4 plus 2/4, that's the same as 1 plus 2/4, which gives us 3/4. Yeah, I'm sure you understand that. So 1/4 plus 2/4 is the same as 1 plus 2/4. So this plus this can all be written over 2. So n squared minus n plus n squared plus n can all be written over 2. So now I can simplify this. So I have n squared plus n squared is 2n squared. Minus n plus n means that they cancel one another out. And this is all over 2. Now the 2 and the 2 can both be cancelled. So I'm left with n squared over 1. And n squared over 1 is n squared. So there you go. We've shown that n is a square number if we put it in that form. Nice and simple. It looks horrible, but it is nice and simple. Okay. So it says the graph of y equals x squared plus 2x minus 3 is drawn on the opposite page. Draw an appropriate straight line on the graph to work out the approximate solutions. Okay. So really, we know that y equals this. We also know that this equals 0, or y equals this. Okay? So this must equal this. So if I have x squared plus 2x minus 3, then this will equal x squared plus x minus 3. Okay? And y will equal all of these. So y will equal this, and it will equal this. So ignore the y for the moment. All quadratics equals 0, so I need to move everything here over to here. So I would have x squared plus 2x minus 3 minus x squared, because it's come over, minus x plus 3. And that would equal 0. Now I can see here that x squared and minus x squared cancel one another out. The minus x and the 2x minus x would just leave me x. The minus 3 and the plus 3 would cancel out. So x equals 0. So I can say that y equals x. Now it says draw the appropriate straight line on the graph to work out the approximate solutions. Okay, so all I need to do now is go to the graph and solve that particular part. Okay, so I'll pause there and I'll go to the graph. Okay, so here we have the graph, and we need to draw in the line y equals x. Okay, because that was what we worked out was the line that we needed to draw. Okay, So I know that it runs at 45 degrees as long as the X and Y axes are the same width apart or scaled the same. Okay, so I know that it's going to run through here and then at 45 degrees here, and I know that it's going to go from here to here, and let's just scroll it down a little bit, and I know it's going to go from here to here. Now I can see that the line crosses here and up here. Okay, so we have to find values for X. So here I can see that the line crosses, so this is there is 2.5, so this is 2.1, 2.2, 2.3, so that seems to be here, so that's minus 2.3, so this will be minus 2.3, that will be one value, and then here I can see that X is 1.1, 1.2, 1.3, so X is 1.3. Okay, so I'll just show you that the line cuts the angle, or cuts the curve, sorry, at this point and this point, and this is what we want, is we want the values for X, and also the values for Y will be the same as well, because it's 50-50 line. So we get 1.3 here, we get 1.3 here, and we get minus 2.3 here and minus 2.3 here. So for X and Y, both values are the same. So X and Y equal minus 2.3, and X and Y equal 1.3. Okay, it's not the easiest question in the world, I have to say, but it's doable. Okay, it's doable. Okay, so what I'm going to do now is stop at this point and then just do one more recording for the last two questions of the paper.